Assalamualaikum warahmatullahi wabarakatuh. I will introduce to you my group member. Firstly, Ahmad Fatul Nazim bin Sulaiman, Muhammad Akil Ahnaf bin Khairuddin, Ramana Syakirah binti Abdul Muttalib, Muhammad Ikhwan Hakimi bin Zulkarnain, and Sarih Muhammad Amin bin Sarih Othman.
Our objective project are to determine the ultimate tensile strength, strain, stress, modulus of elasticity of material and yield strength. Second, to determine mechanical performance. And lastly, to determine the properties and behavior of materials. So the problem statement is to identify mechanical properties of original 316L stainless steel and cold rolled 316L stainless steel in terms of ultimate tensile strength, strain, stress, modulus of elasticity, and yield strength.
Now we will move to the question 3, data analysis. First, we need to plot the stress strain diagram. For the original 316L steel, the stress strain diagram is like this. So for tensile strain, we know that tensile strain is the maximum engineering stress that can be held by the specimen without fracture. Means in this diagram, the tensile strain is the maximum point. So the tensile strain is approximately 563.0504 megapascals. So second, we need to find the yield strength. We know that yield strength is the stress required to produce a very slight yet specified amount of plastic strain. The stress corresponding to the intersection of the 0.002 strain offset. In the diagram, we need to plot the offset strain 0.002 at the x-axis, and then we make a parallel line with this line, and then we the line will intersection with this diagram with this diagram. So the intersection is the yield strength. From the diagram, we can find the yield strength is approximately 261.9505 megapascal. And next, we need to find the modulus of elasticity, E. So from the diagram, we know that modulus of elasticity is stress over strain. So E is the gradient of this diagram. So we know that the equation is y equal to 1128.3x. So y equal to kx. So k is the gradient. So we will get the modulus of elasticity is 1128.3 megapascal. And then we need to find the ductility for original 316L steel. Ductility is the final length minus original length over original length multiply with 100%. So the original length and the final length is given 0.03053 meter minus original length 0.025 meter over 0.025 the original length multiply with 100%, we will get the ductility is 22.12%. We move to cold roll 316L steel. First, we need to plot the stress strain diagram, and then we need to find the tensile strength is the maximum point. So from the diagram, we know that the maximum point is this. So we can find the tensile strength is approximately 978.0952 megapascal. Next, we need to find the yield strength, like question A. we need to plot the offset strain 0.002, and then we make a parallel line with this line, and the intersection we be the yield strength. So the yield strength is approximately 975.9096 megapascal. And next, we need to find modulus of elasticity, E, the gradient. So this is a formula for gradient. We just choose any point in this line, and then we will get the modulus of elasticity is 206,801.3356 megapascal. And the last one is ductility 0.02549 meter minus with 0.025 meter over original length 0.025 multiply with 100%, and then we will get the ductility is 1.96%.
Microstructure and mechanical performance. So, the microstructure characterizations by orientation imaging and transmission electron microscopy revealed that the green structure evolution in the stir zone is primarily dominated by discontinuous dynamic recrystallization. The mechanical properties were also evaluated by the longitudinal tensile tests and microhardness measurements. The obtained results show that despite a 50% decrease in ductility, the highest yield and ultimate tensile strength of the stir process samples are respectively about 1.6 and 1.2 times higher than those of the base metal. In good agreement with the tensile properties, the increased hardness of the stir zone was attributed to the green structure refinement.
So for the conclusion, in the conclusion, Coral 316 LSS is the best material compared to original 316 LSS based on their mechanical properties like high tensile strength and high yield strength.